Let's dive a little bit deeper into reference types. We said that we, the programmers, can define reference types. And how do we do that? Every time we create a class, we're actually creating a new type. It's a very powerful tool. Now, as with the primitive types, we should be able to know what kind of values we can store to a reference type and what kind of operations we can have. For example, we know that if we have an int type, we can have integers, negative, positive, including 0, and we can know the minimum and the maximum value, the range of integer values that we can store in an int type. Also, we know what kind of operations we can have. We can have plus, minus, multiplication, etc. Now, when we create our own type, when we define a class, what are the set of values? Well, every time we create a new object of that class, this is a new value that we just insert to the possibilities of values. So what we create through the new operator is actually defining the set of values for this particular reference type. Also, the set of operations that we are allowed to perform on values of that reference type are defined by the methods that we declare, that we implement inside the class that we're defining. These are the operations that we can perform. Let's take a look again at an example. You probably remember the wheel class. The wheel class had an instance variable of type double, the radius of the wheel, and then we also defined three methods: get circumference, get area, get radius. We implemented those methods. For this example reference type, the wheel, let's figure out what is the set of values and what is the set of operations. Like we said, every time we create a new object through the new operator, that is a new value for the reference type. Assume that we have created an object saying new wheel 15, a wheel object of radius 15. And then assume that we, after a couple of lines of code, we create again a different object by saying again new wheel 15. We have two wheel objects that happen to have exactly the same radius. These are not one value. They don't represent one value. These are two objects, these are two values for this particular reference type, even if they happen to have exactly the same characteristics. How many values can we create for a particular type? We can create as many as the memory of the underlying system, the system where we are running our Java program, allows us. How about the operations? What kind of operations can we do with wheel objects? All the methods that we are defining inside the class wheel are the operations that we can perform. So get radius, get circumference, get area are what we can do with wheel objects. Let's think about a different reference type, the string type. It is different not only because it is a different class than the wheel class, but also because we have not defined it, it is pre-implemented for us in the Java library. What is the set of values? Any kind of string that we can create, any sequence of characters that we can create, is actually a value of this particular type, as long as the length of that string is within the limits that we need. Now, what operations can we perform with strings? All the methods that are defined within the string class are the operations that we can perform, and I strongly invite you to go and take a look at the Java API for the string class to figure out what kind of things you can do with strings. All the methods are very useful and you will find them handy in different tasks. Examples include the concat method. Actually, this is a very special method because we don't really need to use the concat name, but whenever you are using the plus operator between two strings, then that actually concatenates the strings. Other methods are the length method that tells us how long the string is, how many characters it has. The toUpper method, which converts a string from lowercase to uppercase. More details about all of them you can find at the Java API. And the substring method, which comes in different flavors. Again, take a look at the Java API for the string class in order to figure out the set of operations for this particular type. This picture shows us a few examples for both primitive and reference types. It shows us values and operations for each of those types. This will hopefully help you summarize what we have seen already about these two types. For example, the int type. What kind of values can we have? We can have both positive and negative, like 39 and -5. We can also have pretty large values that like 300,000. The kind of operations plus, minus, multiplication, division, and modulo. Another primitive type, the Boolean type. It only has two values, true and false. Operations, the logical AND, the logical OR, XOR, NOT, and so forth. The string type, which is a reference type. Any kind of string we can create is a value for this particular type, like x86 or the name John, etc. Operations, the concatenation, which we can perform with the operator plus. We can get the length of the string, we can inspect a particular character at a particular index position, and so forth. The Java API for the string class lists all the operations that we can perform with strings. Now, perhaps we create our own class for airplane. Then every new airplane object that we create with a new operator is a value for this class. We may have, for example, an airplane object that is of Boeing type and another one that is an Airbus, and so forth. Many different characteristics for each of the planes. What kind of operations can we do with airplane objects? All the operations that are defined by the class itself. How does the class define the operations? Through the methods that it provides. For instance, the airplane class may have a method called fly. It may have a method called land. These are the kinds of operations that we can perform with the airplane type. This particular picture and the examples in this picture are taken by the textbook Start Concurrent. We can find more details about these examples in this particular textbook.